Let's start page 23. Number 114. Find the value of x. Now look at your circle diagram. Notice that we have two chords that are intersecting, and they're giving you lengths and pieces of those chords. When you're trying to solve for x, you have to know the intersecting chords rule. That says you're going to take one piece of the chord times the rest of it equals the other chord times the rest. So here's how I like to write our theorem of intersecting chords rule. Piece times the rest equals piece times the rest. So we're going to take it one chord at a time. So for my first chord, where I see it's cut into 6 and x, 6 is one piece of the chord times the rest of the chord, which is x, equals. Now I'm looking at the other chord. So for my other chord, it's cut into pieces of 3 and 4. So 3 times the rest of it, 4. Multiply those together and let's solve. 6 times x is 6x. 3 times 4 is 12. Divide both sides by 6, and x should equal 2. So x has a length of 2. I don't know if this is inches or centimeters, but it's 2. So this is one theorem that you have to know when you see two chords are crossing somewhere in the interior of your circle. We looked at a diagram similar to this in a previous problem, but we weren't trying to solve for the length of the chords. We were trying to solve for the measure of some of these vertical angles. So it's the same type of diagram, you're just getting different information, and they're asking you for a different portion of the diagram. Okay, let's keep moving on. Okay, number 115. Find the value of x. So again, we're looking at a circle, but now there are chords that are extending outside of the circle and forming an external angle. We looked at a diagram similar to this before, but we were asked to find an angle measure. Here we're looking at the lengths. Now when you see a diagram like this with portions of your chord extending outside of the circle, making secants, you're going to have this rule apply. External times whole equals external times whole. So let's take a look in this diagram and talk about what part is the external and what part is the whole. All right, we're going to talk about one of these secants at a time. So if I'm looking at this bottom secant, the external piece is the 5. So I'm going to put 5 times the whole secant. So from the external angle all the way through to the other side of the circle. So the entire secant here is the 5 and the x together. So I'll refer to that as x plus 5. X plus 5. Looking at your other secant, our external piece is the 6 times the whole secant, which is the 6 and the 4 together, which gives me 10. So times 10. Let's go ahead and solve. Now for the left side of this, you're going to have to distribute the 5 to both terms. So 5 times x is 5x. 5 times 5 is 25. Equals 6 times 10, which is 60. Now we're going to subtract 25 from both sides. So 5x equals 35. And lastly, to get x by itself, you're going to have to divide both sides by 5. X will equal 7. So x has a length of 7. So the important thing for this problem is when you see that angle on the outside and they're talking to you about pieces of these line segments, you have to remember this rule. External times the whole equals external times the whole. Okay, let's move on. Number 116. Read the question and then come back. Okay, so we're asked to find the perimeter of your quadrilateral ABCD. So it's the big quadrilateral on the outside. Now, they give us some measurements here that we need to put into our diagram. DR is 4. DC, the entire top length here, is 10. PB is 8. And AP is 5. Now your goal, again, is to get the perimeter, which means we need all 4 side lengths of this quadrilateral. 1, 2, 3, 4. Now, when you see a circle that has 2 line segments that are tangents touching 2 points on the circle, there's something known as the hat rule that will apply here. The hat rule is like this. If you see a circle, let me change the circle. That wasn't such a great circle. Okay, so here's my circle, much better. And I have 1 tangent and a second tangent. Imagine these are a tangent, that they are touching the circle just at 1 point. The 2 tangents that make up that angle on the outside are going to be congruent. So I'm going to put tick marks here. So if this was 7 inches, so would the other side be. Let's look at your diagram. You actually have a lot of little hats to your circle. So first thing that you should note is DR and DS are 2 tangents to the circle that should have the same measure. Same thing with AS and AP. PB is congruent to QB. And lastly, RC is congruent to QC. So let's start to figure some pieces out here. Let's start all the way at the top. If we have a length of 4 for DR, that means for RC, we're going to figure out that length by doing 10 minus 4, which leaves us with 6 for RC. So if RC is 6, CQ is 6. Next, QB. It's going to be congruent to PB, which is 8. And lastly, AS is 5 on the left. Oh, and we have one more. DS. It's going to be 4. So using that hat rule for all the different sides of this quadrilateral, you figured out their measurements. Now, we need to keep in mind that we want all of the side lengths added together. So we have the entire top. It's DC. The left side is 4 and 5 together, so that's 9. The bottom, it's 5 and 8 together, so that's 13. And the right side is 6 and 8 together, so that's 14. So we're going to grab these 4 lengths, 10, 14, 9, and 13, add them together because that's going to give us our perimeter. And remember, perimeter means adding up all the sides to figure out the length of the outline for a shape. Okay, so let's put in. Our perimeter is going to take 10, 9, 13, and 14 and add it all together in my calculator. Oh, actually, it's a non-calculator question, so we have to do it without a calculator. Okay, 10 plus 9 is 19. 19 plus 13. 3 plus 9 is 12. Add the 1, so now we're at 32. And lastly, add the 14. So 32 plus 14. 2 plus 4 is 6. 3 plus 1 is 4. So 46 for your perimeter. Whatever the units are, inches, centimeters, whatever it is, the answer is 46. Okay, let's keep moving on. Number 117. Convert 45 degrees to radians. Okay, so we're doing a conversion from degrees to radians. This is the conversion rule when you want to convert between degrees and radians. You're going to take your degree measure. Oh, let's go back, fix that. Take your degree measure. You're going to multiply it by pi over 180. And whatever you get is your radian measure. So here we have 45 degrees times pi over 180, and that's going to give you radians. Now, when we're talking about radians and we see pi, it doesn't mean 3.14. Okay, so keep the pi along for the ride. So multiplying 4 times pi over 180, you're going to get 45 pi over 180. If you're not sure how we did that, remember you put 45 over 1 and you multiply across. And that gives you your radians. All we need to do is simplify this. So you want to think about what goes into 45 and 180. And the answer is 45. 45 is a multiple of 45 and 180. So divide both the top and the bottom by 45. And you're going to get pi over 4. So this is going to be pi over 4 radians. So when you're doing a conversion, this is our conversion rule. If you were going from radians to degrees, it would look very similar. You would do the radians times 180 over pi, and that would give you the degree measure. Okay, let's keep going. 118. Use a circle diagram for both part A and B. Part A. Find the area of the smaller sector of circle T to the nearest hundredth. So we're looking for sector area. It's how to find the area of a slice of a full circle. They want your final answer to the nearest hundredth. So that means you are going to multiply in pi. Now, how do we do this? Well, the rule for figuring out sector area looks like this. You take the degree measure of your central angle, which in this case, if they want the smaller sector, they want the orangish pink looking sector here. So this is the degree measure, the central angle of 70. You take your degree measure, you divide it by 360. That's going to give you the percentage of the entire circle that you're looking at for your slice, for your sector. You're going to multiply this by the area formula for a full circle. And whatever you get is the sector area. So let's start plugging some things in here. The degree measure we said is 70. That's your central angle over 360 times the area of a circle. Now, we don't have the area. They didn't give it to us. So we have to think about what's the area formula for a circle. And the answer is pi r squared. Our radius here is 8. So we're going to plug in pi times 8 squared. And whatever we get should give us our sector area. So now 70 over 360 times pi times 64, or 64 pi. That's what 8 squared is. The rest of this, I'm going to do this in my calculator to get my sector area. So grabbing the calculator, 70 divided by 360 equals. So it's about 19% of the entire circle that we're looking at. Times pi times 64 equals. Okay, so our final answer is 39. And now rounded to the nearest hundredth, it's going to be 0.10 inches squared, because it's area, sector area. Okay, let's fill this in. Our answer is 39.10 inches squared. Part 2 of this question says, find the length, now we're looking for length, of arc USV to the nearest hundredth. Okay, so we're looking for the length of this arc. Now, we're not actually looking for the length of the pie slice that we were looking at. We're looking at the rest of the circle. So I want to go over the formula that we're going to use here. So I'm going to clear off some space. Okay, so just like before, we're going to have a similar formula to find length of an arc. Now, to figure out the length of an arc, your formula is going to look like this. Degree measure over 360 times, in this case, since we're not talking about area, we're talking about length, you're going to multiply it by the circumference formula for the full circle. And that's going to give you arc length. So let's start by thinking about, well, what's our degree measure? When I'm looking at arc USV, I'm not going to use the 70. I have to use the rest of the circle. So I first need to figure out, well, what is that length? Or sorry, what is that measure? So 360 minus 70 gives me 290 degrees for the rest of the arc USV. So 290 is the degree measure for the arc that I'm going to use in my formula. 290 over 360 times the circumference formula. So your circumference formula is 2 pi r. And we don't have the circumference. We have to figure it out ourselves. So I'm going to plug in 2 times pi times our radius of 8. And that's going to give me the length of the arc. Arc length. Okay, grab my calculator. Let's go ahead and do all this multiplication. 290 divided by 360. So this is approximately 81% of the entire circle's circumference. Multiply this by 2 times pi times 8 equals. So approximately 40.49 if we round to the nearest hundredth. 40.49 regular inches, because we're talking about the length of the outline, the length of the arc, will equal your arc length. Okay, let's write that in. Final answer, 40.49 inches. So two formulas we went over in this problem. They're both very similar. One of them, you're going to do the degree measure over 360 times the area of a circle. That's if you want to find sector area, the area of a little slice. The second formula that we went over was if you want to find arc length. So same thing, you're going to do degrees divided by 360, but now we're multiplying by the circumference of the circle because we're talking length. Circumference is the length of the outline, so we use a circumference formula. Both formulas are very similar. Just pay attention to the fact of whether or not you need the length of the outline or do you need the area of the slice. Okay, let's move on. Number 119. Find the volume and surface area of the square pyramid shown. So pretty straightforward ask. They want the volume, they want the surface area, and they tell us it's a square pyramid. So looking at this shape, when I see the 10 inches for one of my side lengths, I know that for the other side it's also going to be 10 inches. All four sides are going to be 10 inches. We need to round our answers to the nearest tenth if necessary. Okay, let's start with volume. Now to find volume, since you see a big point at the top, an apex, your generic volume formula that we're going to write down is V equals 1/3 big BH. That 1/3 part is there because you see a point at the top. So this doesn't just work with pyramids, it also works with cones because there's a big point at the top. Okay, now remember that big B stands for area of your base. It's hiding an area formula behind it. And H stands for height. Now we have a little bit of an issue here. We don't have the height. The 17 inches is the length of your slant, but it is not your height. If I were to go ahead and draw in my height, it would look like this. It's going to go to the center of that square, and it's going to be perpendicular to your base. That is your height. So what we need to do is we need to solve for it before we can even use our volume formula. I'm going to zoom in on this so we can talk about it a little bit more. Okay, so I've drawn in my height. Now, when it comes to pyramids and cones, one thing I will tell you is that if you're missing a height or you're missing a slant length or you're missing a side length, you can always solve for those things using Pythagorean theorem or trig. Now, the question is, well, how? Well, we see this height drawn in, and we also see this slant. And if we connect them along the bottom, we see a little right triangle on the interior. We know what the length is for that bottom side of the right triangle. It's going to be 5 because the entire side length here is 10. So we're starting at the center, which is halfway, going to one side of the pyramid. It's going to be 5. So look at what we have. We have a right triangle with side lengths of 5, h, and a hypotenuse of 17. Let's go ahead and solve for h. Using Pythagorean theorem, not trig because we don't have an angle, Pythagorean theorem, we're going to start setting up 5 squared plus h squared equals 17 squared. 5 squared is 25 plus h squared equals 17 squared. 289. Subtract 25 from both sides. H squared equals 264. But we want just h. We just want the height, not the height squared. So we're going to square root both sides. So the square and the square root cancel. So your height, let's see if it's a nice pretty number. Nope, not a pretty number. So we're going to leave it as square root of 264 for now. You don't want to round early. So our height is the square root of 264. So I'm going to write square root of 264. Now we're ready to find the volume because we were missing the height before, but now we've solved for it. Okay. Okay, so let's go. Volume equals 1/3. Your big B stands for area of your base. Since your base is in the shape of a square, we're thinking length times width or side length squared. I'm just going to write length times width. I think you identify with that much quicker. And then the height, we just figured out before, is square root of 264. Let me keep going and plugging things in. 1/3. Your length and your width for your base are 10. Both of them are 10. So 10 times the 10 times the square root of 264. Now, this is all calculator work. So going to the calculator, we're going to start with the 10 by 10. I always like to start right here, 10 by 10. 10 times 10, you should know, is 100. Times, now I'm going to do the 264 square rooted. So 264, hit the square root button. It tells you that's the square root of 264. Now hit equals. So it's 1,624.8 before we multiply by a third. Instead of multiplying by a third, I'm going to divide by 3. It's the same thing, but it's easier calculator work. So hit divided by 3 equals. Okay, so our volume, if we round it to the nearest tenth, excuse me, round to the nearest tenth, 541.6 inches cubed is going to be our volume. So 541.6 inches cubed. Okay, let's go ahead and figure out surface area now. I'm going to erase this so that I can give myself some room to write. Okay, so surface area, that means you're going to take the area of all of the sides and add them together. All right, well, let me think about this. So for surface area, we always do the lateral area plus, in this case, only one base because it's a pyramid. Let's keep going. Surface area. Okay, lateral area is a whole bunch of triangles. It's all the faces of your pyramid. All those triangles are going to be congruent because they all have a base length of 10. So what I'm going to do is I'm going to write down I have 4 triangles. Plus, I have a base, which is a square. Okay, let me keep going. So to get surface area, 4 of identical triangles, I need to put in what's my triangle area formula. Base times height divided by 2. So I have 4 triangles, and to get the area of one triangle, I do base times height divided by 2. Okay, and then I need to get the area of my base, which is length times width, because it's a square. Okay, let's keep plugging in. 4. Now my base and my height, thinking about just the triangle. The base of the triangle is 10. The height of the triangle is that 17 that's slanted. That 17 was the height of my triangle, not the height of my entire pyramid. So that 17 is going to be used now to figure out the lateral area, or the area of each one of the triangles. Okay, so let me plug in. I have 10 for my base times 17 for the height of the triangle, all over 2 to get the area of just one triangle. Okay, plus the area of the base, which is 10 by 10. So 10 times 10. All right, let's keep plugging in. So to get surface area, let me go ahead and do the multiplication that's shown here. So to my calculator, 10 times 17 equals, divided by 2. That's the area for one triangle. It's 85 square inches. But I have 4 of them. So I'm going to do times 4 equals. Okay. 340 inches squared is the area of the lateral portion, all of the triangles. All right. And now 10 times 10 for my base. That's 100. So 340 plus 100 is going to give me 440 inches squared for the entire surface area. So for all of the surfaces added together. I'm going to put in 440. Now, questions I would ask you about surface area is if you're making this shape, if you want to make this shape out of plastic or you want to make it out of aluminum, you need to figure out, well, how much material do you need to make the shape? You're finding surface area. So that's an example of when you would do surface area. Now, if they're talking about volume, they would say things like, well, how much air is inside? Or how much does it take to fill the pyramid? Or what's the capacity of the pyramid? So these are all concepts that would be used to find volume. This was pretty straightforward. They just wanted you to practice getting volume and surface area. The only trick is that you were missing the height to find volume. But you did have the height to find surface area because it's a different type of height. Okay, that completes this page. Let's keep it moving.